Hi, Michelle Glass here. Welcome back to another one of our digestive system lectures. I'm actually pulling information here from our chapter 18, which is our endocrine chapter. We're going to be taking a few minutes putting together the details of glucose regulation. We've talked a little bit about this as part of our previous digestive system discussions and also as part of our endocrine system discussions, but I did want to make sure this was adequately covered. Okay, so in order to begin, let's take a look at our normal blood glucose levels, which are 70 to 110 milligrams per deciliter. Now, I don't really think that you need to have this memorized per se, but probably you'll see this in future personal blood work information or as part of a health-related professional program. So go ahead and start thinking about what is normal here. Of course, internet is easily accessible, and so we can look up this information that way. So we won't have any real test questions on that number. What we are going to be looking at are the mechanisms of how our body handles when our blood glucose is too high and too low. When your levels are too high, we'll see the production of insulin, which is our hormone, remember, that's going to take that glucose and put it into our cells. And we'll look at that mechanism a little bit more. And on the flip side of that, if our levels are too low, the hormone glucagon is going to coordinate what we've described in the past as glucose-sparing activities. This is a negative feedback mechanism, so you are looking at your figure 8 sort of response here. Instead of a diagram, I've just kind of mapped it out for you. So when our glucose levels are too high, the beta cells from the pancreas release the hormone insulin. Insulin is going to tell our somatic, our body cells, to increase the uptake and use of glucose. Glucose is abundant, so our cells are going to take it in and use it for glycolysis and cellular respiration and make a bunch of ATP. Because we have lots of ATP, we can also increase our amino acid uptake and protein synthesis. Your skeletal muscle cells and your liver cells both can make glycogen, which is a polysaccharide storing glucose. And your adipocytes are going to increase their triglyceride production, storing fatty acids. And these activities will bring your blood glucose levels to normal. This is all characteristic of the absorptive state. So when we're eating food, we're flooding our blood with carbohydrates, with glucose, with amino acids, with fatty acids, lots of nutrients. So let's use them, right? And so that's how we're going to see our cells using the glucose, using the amino acids, and storing those fatty acids for later. This is all typically, when we're awake and we're eating and our metabolic rate is highest. Looking at the flip side of things, when our glucose levels are too low, we have our alpha cells of our pancreas releasing glucagon. Glucagon is responsible for all these glucose-sparing activities that we've talked about before. Liver cells can actually make more glucose. So they're going to do what's called gluconeogenesis, taking amino acids and lipids and using that to make glucose. Skeletal muscle cells can break down the stored glycogen and release glucose that way. Adipocytes are going to break down triglycerides and release the fatty acids. So we have glucose being made, glucose being released so that your neurons have glucose to use and you're also maintaining your blood glucose levels. And the rest of your cells are going to be using the fatty acids released by these adipocytes to make ATP. This is characteristic of the post-absorptive state when you're not absorbing nutrients from your meal and instead you're restricted to whatever you have stored in the body. But that's typically, when you're asleep and your metabolism rates are low. Now, if you have problems regulating your blood glucose levels, that's going to be described as diabetes mellitus, which is characterized by an accumulation of glucose in the blood, and essentially it's making it too thick. And all of the symptoms and problems associated with diabetes mellitus, if you look at them, basically you see it's problems with the cardiovascular system because that blood is so thick, it's not moving well through, it's causing damage, you're not getting good blood flow to all of your tissues. Now there's two types we've talked about in the past. Type 1 is described as inadequate insulin production. So this was historically talked about as juvenile diabetes because we do typically see this showing up with young people. And there's a genetic component to this. Type 2 diabetes is referred to more as insulin resistance. So those individuals are usually making enough insulin, but their cells have stopped responding. This is often associated with obesity and can show up then regardless of age. And so we are seeing type 2 diabetes showing up in young people due to obesity epidemic. All right, and that is the end of our chapter 24.